Hey, differential equation students. Our focus starting today is on systems of differential equations. What we mean by that is situations where we have two variables, like here in number 2, x1 and x2, and differential equations for both. And what we want to focus on is converting between one differential equation and two differential equations. Let me show you how this works for number 1. Notice in number 1, we have one differential equation in terms of u, and it's second order. Let's define a new variable. Let's define v to be u prime, the derivative of u. So v prime is u double prime. Now notice what that means I can do. I can take this equation and say u double prime, that's v prime, so v prime plus 6 times u prime, we'll write that as v, plus 5 times u is equal to 0. And we already know that u prime is equal to v. So we can think of this as a system of two differential equations. V prime equals negative 5u minus 6v, and u prime equals v. So what we just did there is we took that second order differential equation in one variable and converted it into two first order equations using two variables. Let's go backwards. So in number 2, we're going to start with the system that I have here, and then we're going to convert it into one second order differential equation. Let's take that first equation up there, and let's solve for x2. x2 is x1 prime minus 2x1. All right, so that tells me that x2 prime, the derivative of x2, is x1 double prime minus 2 times x1 prime. Now that we have that, let's plug everything into this second differential equation. So x2 prime we just found. That is x1 double prime minus 2x1 prime equals 3x1 plus twice x2. And let's plug in what x2 is from over here. That is x1 prime minus twice x1. So let's see what we're going to get here. We're going to get x1 double prime. We've got it minus 2 times the derivative here, plus 2 times the derivative over here. So when it moves over, we'll get minus 4 times x1 prime. And we've got 3x1 minus 4x1. That's going to be minus x1. When we move it over to the other side, we'll have plus x1 equals 0. So notice what we just did there. We took a system of two first order differential equations and transformed that into one second order differential equation. Notice that as soon as we can solve for x1, we can plug that into here and we'll know what x2 is. So this is one solution technique that we'll use. It's not the most common solution technique. We'll find easier ways to talk about it than this. But it's one way of taking a system and breaking it down to something that we already know how to solve.